When it comes to scientific experiments that need to be conducted in space, the subject matter always intrigues us. We've had experiments like growing plants in space or letting animals float in zero gravity, but there is always one experiment that never gets an actual trial, and that is, what would happen if you fired a gun into space? Now, we have seen a lot of science fiction movies where giant spaceships battle across galaxies. They start firing strong weapons, but no real damage seems to occur in any way unless it is them taking the hits. Can this actually happen? Well, according to physics, this action would be false, as these sorts of encounters with firing arms would need them to defy the laws of motion. In reality, if you exert force in space, it will always be countered by an opposite force. The question we're going to answer here is, what would happen if you were to shoot a bullet in space? Well, let's look at a gun first. When you look at the mechanism of this weapon, it works by using the power of force, oxidation, heat, and fire to allow the bullet, which is in a state of inertia, to propel out of the chamber of the gun. However, when you think about firing a gun in space, there is one important factor missing. Space has no air, which means that if there is no air, then how would bullets fire? So if you're using gunpowder, then this experiment wouldn't work. However, you should know that modern ammunition contains an oxidizer, which is a chemical that allows combustion to happen when there is no air. So we are going to use a modern day gun here. It's got a cartridge filled with bullets. It's enough for it to work in space as well as on Earth. The only differences would be that 1, there is no gravity in space, and 2, there is no friction to affect the motion of the bullet. When you fired the gun, you wouldn't be able to hear the gun explosion because there is no air to propagate the sound waves in space, unless you used it in a spacecraft, which of course would not be the smartest idea. Additionally, the smoke would simply spread out in a sphere from the barrel's tip rather than leave a wispy vapor trail like we see in the movies. If you take a gun that is shot on Earth, gravity and friction allow the bullet to travel only to a certain distance at a certain speed. However, in space, gravity and friction do not impact the distance and speed, which makes the end result completely different. You're not the first person to ask this question. It was Matthew Cook, a Harvard astronomer, who first questioned this phenomenon. He came to a conclusion through the application of scientific theories that when a bullet is fired into space, the bullet will continue to travel at the same speed till the end of the universe, or until it hits a surface. He concludes by saying that the bullet will never stop. But why do you think the bullet will never stop? It doesn't make sense, right? If you look at the information gathered about space, it's actually growing faster than a bullet could ever go. Hence, the only explanation for this phenomenon is that it will never collide with anything. Of course, this theory assumes that the gravity of a star or planet would not be close enough to cause the bullet to be drawn into its orbit. But keep in mind that compared to the vastness of empty space, anything with mass, such as stars and planets, actually occupy a relatively small portion of the cosmos. Therefore, the chance of it happening is really low. The shooter must also prepare for the kick or recoil that occurs when a gun is discharged. In addition to potentially hurting the shooter, holding a pistol incorrectly can also make it difficult to aim. One of the fundamental laws of physics, Newton's third law, states that there is an equal and opposite response to every action, which is what causes recoil when firing a gun. In the absence of gravity and friction in space, this means that the shooter will move in one direction while the bullet moves in the other direction. The speed at which a shooter and bullet are launched in the opposite directions depends on the shooter's velocity and the bullet's weight. Shooting a tiny pistol with a slower moving but heavier bullet will propel the shooter in the opposite direction at about twice the speed of a rifle. The shooter will move backward at 0.68 miles per hour. Now imagine yourself as an astronaut orbiting the Earth, perhaps on a spacewalk, and sufficiently removed from your spacecraft to be able to use a weapon without endangering your crew. At that altitude, everything is circling the Earth, including you and your space vehicle. If you shot your pistol at exactly the right angle, the bullet would also orbit the Earth. This would be a problem, and here's why. Since orbits are circular, the bullet will eventually make a full revolution around the Earth and come back to where it started. Given that you are currently in the path of the bullet and the area to which it is returning, you will have actually shot yourself in the back. Now, if all of this seems a bit speculative rather than realistic, keep in mind that scientists have thought about self-hits in space. No one has actually tried it, despite the fact that it is intended to study interactions with small asteroids, space debris, and other objects. It turns out that the idea of using firearms in space is more real than imagined. There was actually even an experiment carried out by the Russians, and although they used cannons instead of guns, the results were the same because both weapons operate according to the same principles. According to previously undiscovered records that were uncovered after the fall of the Soviet Union, it occurred in 1975. The entire experiment was run remotely from the ground. The scientists attached the cannon to the Salyut 3 spacecraft, pointed it in a specific direction, and fired it 3 times. Since the Soviets were well aware of Newton's third law, they turned on the rocket engines on the spacecraft to counteract the rebound from the explosions. The results of the experiment are still classified. Regardless of the cannon's intended target, one could logically assert that its projectiles are still traveling through space today. Guns in space aren't just a fantasy for Soviet and later Russian space projects. For a long time, cosmonauts transported weapons into space, but they weren't intended to be fired while in space. When the American space program first started, astronauts would return and land in the middle of the Pacific Ocean, where the Navy would then rescue them. The Russians, on the other hand, sent their cosmonauts back onto solid ground. They would usually arrive in Kazakhstan's huge grasslands, where they would often have to stay for hours or even days before help arrived. As a result, they were and still are given survival kits that contain food rations, first aid kits, and in the past, guns in case they encounter dangerous wildlife or possibly hostile locals. Although the Russian Space Agency has declined to comment on the topic, Orbit writer James Obert believes that Russia has ceased providing weapons in the kits that cosmonauts take into space. Do you consider this response to be appropriate? Please share your opinions in the section below, subscribe to our YouTube channel, and click that bell to make sure that you don't miss any future videos just like this.